Hello everyone, I am Rafaela from Ben, and today I will be presenting our findings on the Fabapalooza customer retention. Our goal was not just to predict churn, but to build a financial strategy that maximizes company profits. So let's start with the challenge. Fabapalooza serves startups, which means that the customer turnover is naturally high. However, we are losing too many established customers, and that hurts our long-term revenue. We have a retention budget, but it's quite expensive, costing around 20,000 euros per customer intervention. This creates a massive dilemma. If we try to save everyone, the cost will bankrupt the problem. If we do nothing, we lose valuable customers. We started with customer records from 2010 to 2025. Crucially, we did not use a standard random split. We used a temporal split. We trained our models on the data prior to 2025 and then tested them on that year data. These simulate real-world problems. We trained on the past to predict the future, and if our model works here, we can be confident deploying it for the future years. We also used a five-fold cross-validation with 4 repeats strategy to make the most of our data and reduce test error. Model strategy. We entered 3 candidates into our model bake-off. First, logistic regression. Our baseline. It's simple, linear, and highly interpretive. Second, boosted trees. A complex model known for detecting difficult, nonlinear patterns such as churn behavior. Third, random forest, an ensemble method that usually offers a balance between stability and occurrence. Here is how they performed. If you look at the ROC-AUC column, they look similar, all scoring between 0.67 and 0.69. But the real story is in the sensitive column. In other words, how is their ability to catch churners? Look, for example, at the logistic regression. It has a sensitive of only 0.238. It's extremely conservative. Compare that, for example, for the boosted tree or random forest, which both are over 0.53. They are catching more than twice the amount of at-risk customers compared to the baseline. To understand why this matters, we need to define our 2 main levers. On the left, we have sensitivity. This is our catch rate. High sensitivity means we don't miss churners. On the right, we have specificity. This is our safety rate. High specificity means we don't waste money disturbing happy customers. Usually you can't have both. You have to trade one for the other. Here is the proof in data. This is called confusion matrices, where we compare true positives, false negatives, and true negatives calculated from each model. Look at the logistic regression on the left side. It has very few false positives, so it's a safe model. But look at the red number, 305 false negatives. This means that we lost more than 300 customers without the model even realizing they were leaving. Now, look at the random forest on the right side. We caught 214 churners, way more than the logistic model. Yes, we have more false alarms, but in a high-value business, catching the churner is worth the risk. So, to summarize the behavior of these 3 models, we made this comparison. The logistic regression is the conservative bet. It avoids costs but loses customers. Boosted tree is the aggressive hunter. It catches everyone but wastes budget on false alarms. And the random forest is the balanced strategist. It compromises perfectly between detection and precision. But which one is the makes the most money? Here is where we pivot from data science to business strategy. A high accuracy score is nice, but we need the ROI when we talk about business. We calculated the expected profit for every single customer using the following formula. We take the probability of churn, multiply it by the customer's spend, and then subtract the 20,000 retention cost. To decide on which customers to contact, we follow a simple three-steps process. 1. Compute expected profit for each 2025 customer. 2. Rank all customers from highest to lowest profit. 3. Use the profit curve to find the point where cumulative profit peaks. Using this information from the profit curve allow us to know exactly the optimal point of customers Fabapalooza should contact. By using this process, we will be able to rank all the customers not just by their risk of churning, but also by their financial value that Fabapalooza could gain from calling them. So instead of only focusing on contacting everyone the model labels as risky, we focus more on the customers who would generate the highest financial return, hence making the 20,000 retention cost worth spending. On this slide, you can see the profit curves I was talking about. See how each model translates into cumulative profit after running the model. The red curve shows the model-based strategy, and the blue dashed line is what happens if we contact customers at random. This green dot marks the optimal contact rate for each model. Logistic regression peaks when we contact about 13% of the customers and delivers around 2.13 million in profit. The boosted tree curve goes higher, reaching roughly 4.89 million, and the random forest curve dominates by contacting about 40 to 41% of the customers. It reaches the highest peak with an expected profit of about 5.91 million. Overall, on all the model, the profit curve shows we always do better when using information gained from the model rather than just contacting customers at random. So, how all of this translates to clear decision making for Fabapalooza? We translated each model into practical business plans. Plan A, balanced profit strategy, uses the random forest model. It targets top 40% of high-risk customers and delivers the highest overall profit, around 5.91 million euros. Plan B, long-term value, is based on the boosted tree. It focuses on about 30% of the high-risk customers, and it's well suited when we want to capture as many valuable relationships as possible while respecting the internal contact constraints, generating about 4.89 million in profit. Finally, Plan C, cost-focused strategy, uses logistic regression. It contacts only the top 13% of the highest risk customers, keeping intervention costs low while still generating approximately 2.13 million in profit. Together, these three plans give Fabapalooza a flexible menu depending on the budget and Given the objective to grow sustainably while using the retention budget efficiently, we recommend starting with Plan A. Plan A is preferred because for our goal of maximizing profit, its random forest curves delivers the highest projected profit and dominates the others for most feasible contact rates. Concretely, this means ranking customers by expected profit, then contacting the top 41%, or about 500 customers, which is projected to deliver almost 6 million in revenue. I hope you all liked this presentation and we are open for discussion.